Hello, and welcome to the Sleepy Minds. I'm so glad you're here. Whether you're curled up under soft blankets, resting on a sun-warmed porch, or simply letting your thoughts drift like clouds across a quiet sky, this video is your gentle invitation to breathe a little slower and wander with me through one of the strangest mysteries in all of science. Tonight, we're stepping into the unseen, not into a black hole, not into a cell, but into something far stranger. We're going to explore time, not the kind ticking on your phone or measured by the seconds racing past in a to-do list, but the deep kind, the kind that whispers through the birth of galaxies, the beating of your heart, and the fact that no matter what we do, tomorrow always follows today. What is time, really? We use it constantly. We measure it, sell it, race against it, lose it, waste it, and wish we had more of it. But if you pause, really pause, and ask, what exactly is time? Suddenly, everything gets fuzzy. Because for something so ordinary, time refuses to behave. You might think time is just a line, a simple, straight arrow always moving forward. But is that just the way we experience it? Is time real, or just an illusion made by the mind? Let's start at the beginning, or at least the beginning of how we think about time. In ancient days, time was tied to the heavens. Before clocks, before calendars, before digital timestamps and alarm tones, people looked to the sky. The movement of the sun, the cycle of the moon, the migration of stars. All these cosmic dances gave shape to our earliest sense of time. A day, a night, a season, a year. But these aren't time itself, they're rhythms. They're changes. And maybe, just maybe, that's all time really is, a record of how things change. Let's ask a simple question. If nothing changed, if absolutely nothing moved, nothing ticked, nothing aged or decayed, would time still exist? It's hard to imagine, because even thinking requires change, a shifting of chemicals, a spark of neurons, a ripple in your brain. No change, no thought. No change, no time. So could it be that time is not a thing, but a measure of change? You wake up, you check your clock. It says 7 a.m. But what does that mean? It doesn't really tell you anything about time itself. It's just a convention, a shared agreement based on spinning earth and moving hands. It gives you structure, yes, but it hides the deeper truth. Clocks don't measure time. They count repetitions of a pendulum, of a crystal vibration, of the earth turning once more toward the sun. But time itself may not tick. It may not flow. It may not even be real. At least not in the way we imagine. Let's dig deeper. When you close your eyes and think of time, you probably imagine it as a line. The past behind you, the future ahead. You walking through it one moment at a time. But according to Einstein, that image is all wrong. In 1905, Einstein introduced something that would break time in half: special relativity. And with it came a truth so strange it still feels impossible. Time is not fixed. Time is not universal. Time stretches. If you move fast enough, really fast, time literally slows down for you. This is not metaphor. It's not you feel like time slows down. It actually does. Your clock ticks more slowly. Your heartbeat stretches. Even your aging slows. This is called time dilation, and it's not just theory. We've measured it. Astronauts who spend long periods in orbit, moving at high speed, actually return to Earth having aged less than the people they left behind. It's only a fraction of a second. But it's real. Two twins. One stays on Earth. One goes to space and comes back. And suddenly, they're not the same age. That's not science fiction. That's science. So here's the thing. Time, it turns out, is relative. It's tied to motion and speed and gravity. It means there's no single cosmic clock ticking the same for everyone. Time is not a universal backdrop. It's more like a local fabric, shaped and stretched by what's around it. And here's where it gets even weirder. Let's imagine a mountain. And at the top, a man with a watch. At the bottom, another man with the same watch. They compare notes. The man on top, his watch runs faster. Why? Because gravity affects time. The closer you are to a massive object like Earth, the slower time moves for you. This is called gravitational time dilation, and we've confirmed it using satellites and atomic clocks. In fact, your GPS wouldn't work without accounting for it. Your phone relies on satellites orbiting above Earth, where time runs a little faster than it does on the surface. If we didn't correct for that, your maps would be completely wrong within minutes. So, time isn't just personal. It's environmental. Now pause. Breathe. Let's go inward. Because all of this is fascinating, but it doesn't explain something even more mysterious. Why does your time feel the way it does? Sometimes minutes crawl. Sometimes hours vanish. You've lived days that felt like weeks, and weeks that disappeared like sand through your fingers. So what's going on? This is subjective time, the way our brains experience the passage of moments. And guess what? It doesn't match the clock. Your brain doesn't track time like a stopwatch. It's more like a storyteller, piecing together a sense of duration from your experiences, your emotions, your attention. When you're bored, your brain takes in less detail. So afterward, it feels like time dragged. When you're stimulated, traveling, laughing, falling in love, your brain records more. So later, it feels like time flew by, even though you packed more in. And as we age, time feels faster, because each year becomes a smaller percentage of our total life. A single summer when you're 7 is huge. At 47, it's a blink.
This is just part 1. And already, time feels slippery. It bends. It stretches. It deceives. So what is it really? Is it a river we float down? A mental construct? A byproduct of entropy? Or a dimension as real as space? That's what we'll continue exploring. From thermodynamics to the quantum realm, from the illusion of the now to the very beginning of the universe itself. But for now, let your mind drift. Let your heartbeat slow. Because here at the Sleepy Scientist, we're not in a rush. We have all the time in the world. Think about how we measure time. We've built entire civilizations around it, carving it into days, hours, minutes, and seconds. We've invented calendars, atomic clocks, and countdowns. But none of those are time itself. They're just tools. Measuring sticks we've crafted to make sense of something that doesn't always behave. For centuries, time was defined by the heavens. Ancient cultures used the movement of the sun and stars to shape the year. A sundial casting a shadow, a moon completing its phases, the equinox arriving right on schedule. Time was celestial, woven into the rhythms of the cosmos. Then came the mechanical clock, ticking away inside bell towers and city halls. For the first time, time became public, collective, and slowly industrialization turned it into a resource to be used, sold, scheduled, and controlled. By the 20th century, we reached the atomic clock, using the vibration of cesium atoms to count time with astonishing accuracy. Today, the official definition of a second is based on 9,192,631,770 vibrations of a cesium-133 atom. That's precision beyond imagination. And yet, even with all that technology, we're still chasing what time really is. Because no matter how you measure it, time seems to escape full understanding. It flows until it doesn't. It stretches unless it snaps. It moves forward except when it bends. Let's take a gentle step back and revisit something strange. You've probably heard the phrase time is an illusion. It's been whispered by philosophers, muttered by theoretical physicists, and echoed in spiritual teachings for millennia. But what does it actually mean? In the realm of physics, it often points to the idea that our experience of time, flowing from past to future, might be a trick of perception. Einstein himself once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." That doesn't mean time isn't real, but it might not be what it feels like. When you remember your childhood, that memory is activated now. When you plan tomorrow, that plan lives now. In your mind, the past and future are recreated in the present moment, the only place you actually exist. So from one perspective, there's only now, always now. Your entire life has unfolded in a series of ever-changing nows. The rest is memory or imagination. Let's go even deeper. There's a theory in physics called loop quantum gravity. It suggests that space and time are not continuous, but instead made up of tiny, indivisible units, like pixels on a screen. In this view, time itself may be quantized, made of tiny chunks, smaller than anything we can currently detect. That would mean time doesn't flow smoothly, ticks at unimaginably small scales. But if that's true, why don't we notice? Because to us, those ticks would be like grains of sand in a desert, too small to feel individually, but collectively giving shape to the landscape of our lives. Even stranger, some physicists speculate that time might emerge from something more fundamental, something beyond our current understanding. In this picture, time isn't a basic ingredient of the universe. It's something that emerges from the relationships between things, from interactions, from change. Time then isn't out there. It's something that appears when matter and energy interact in just the right way. And that brings us to a truly mind-bending question. Could the universe exist without time? In certain equations of quantum gravity, particularly the Wheeler-DeWitt equation, time disappears completely. It doesn't even show up. These models describe a universe that exists in a kind of timeless state, where nothing changes because there's no time to change within. To us, that sounds impossible. How can a universe exist without anything happening? But here's the catch. From within that timeless universe, consciousness, observers like you and me, might experience change anyway. We might still feel time, still remember, because our perception of time may not reflect reality itself. It may just be the way a limited mind makes sense of a deeper truth. Let's bring it closer to home. Have you ever had a dream that felt like it lasted hours, but only took seconds? Or sat in meditation or in grief where time either froze or collapsed entirely? These are not glitches. They're reminders that clock time and psychological time are different. The ticking of a second hand is mechanical, but the feeling of time, that's deeply human. In moments of love, time softens. In fear, it sharpens. In wonder, it dissolves. And maybe, just maybe, that's why we can't pin it down. Because time isn't something we're outside of. It's something we're inside. We are not observers of time. We are made of time. Let's rest here for a moment. You've been walking slowly, gently, through the mystery of time. Not to solve it, not to conquer it, but to let it unfold like a spiral. Maybe time is a direction. Maybe it's a dance. Maybe it's an echo, or a story, or a structure our minds use to navigate the strange gift of being alive. Whatever it is, it has brought you here, right now, to this moment, to this breath. And if that's not magic, what is? The shape of time. Time has no scent, no texture, no shadow you can trace across the floor. And yet, we feel it more deeply than anything else. It shapes our lives, our memories, our hopes, and our fears. But what if time itself has a shape? What if, instead of ticking forward in a straight line, time is something far more fluid, more complex, and maybe even more beautiful? To explore this, we need to step into Einstein's world. Before Einstein, time and space were separate. Time was the ticking of a universal clock, and space was the stage upon which the universe played out its scenes. But Einstein changed that. With his theory of relativity, he showed us that time and space are not distinct. They are woven together into a single fabric, space-time.
This fabric bends, it stretches, and it warps in the presence of mass and energy. In Einstein's universe, the more massive an object, the more it curves space-time around it, and that curvature is what we feel as gravity. But here's the twist. Gravity doesn't just bend space. It bends time too. Imagine standing on the surface of Earth. Time for you is flowing just a tiny bit slower than it is for someone floating above the planet in orbit. The difference is minuscule, nanoseconds, but it's real. It's measurable. And if you stand next to something truly massive, like a black hole, time slows down drastically. So much so, in fact, that to an outside observer it nearly stops. This phenomenon is known as gravitational time dilation, and it's not science fiction. It's been confirmed through experiments using satellites and atomic clocks. In fact, your GPS wouldn't work if engineers didn't account for the difference in time between satellites orbiting above and clocks ticking here on Earth. So, already, time reveals itself not as a universal rhythm, but as something that flows differently depending on where you are and how fast you're moving. This is the shape of time. Flexible, relative, curved by the very presence of matter. Now imagine zooming out, far, far out. Picture space-time as a vast, four-dimensional landscape, not just a map of places but of events. Every point in this landscape marks a specific location and a specific moment. Your birth is there, the first time you laughed, the last time you watched the sunset. Every memory, every heartbeat, etched into this grand cosmic quilt. Physicists call this the block universe, the idea that all moments in time, past, present, and future, coexist equally. Like pages in a book or frames in a film reel. You don't feel all the pages at once, but they're all there. In this view, the flow of time, the feeling that we're constantly moving forward, is a feature of our consciousness, not of the universe itself. To most people, this sounds unsettling. If the future already exists, do we have free will? Are we just passengers in a script that's already written? But maybe that's the wrong way to think about it. Instead of seeing time as a line we're walking along, maybe we're like flashlights, illuminating one moment at a time in a vast, timeless gallery. Each moment we visit feels present, but all the other rooms still exist. This idea resonates strangely with memory. Think of a vivid memory, the smell of rain, a loved one's voice, a childhood room. In a sense, you're not remembering, you're visiting. Your mind is time traveling, reconstructing the sights, sounds, and emotions of a moment long past. And sometimes our minds do this involuntarily. Trauma, nostalgia, déjà vu. All are reminders that time in the human brain isn't linear. It loops, it folds, it even collapses. Psychologists have found that our perception of time varies with age, mood, and even language. To a child, a year is an ocean. To an adult, it's a breath. When we're in danger, time seems to slow. When we're in love, it disappears. One theory suggests this has to do with how we record information. In intense or novel experiences, our brains take in more details, making time feel stretched out. But in routine, our brains compress the memory, making it feel shorter. That's why a vacation feels long while you're on it, but short in hindsight. And why the years seem to speed up the older we get. So maybe the shape of time isn't just cosmic. Maybe it's also personal, woven into the folds of your brain, your heartbeat, your breath. And deep inside your biology, there's a clock, ticking away not in seconds but in molecular rhythms. This is the circadian clock, the internal system that governs your sleep, hunger, body temperature, and more. It's not set by a wristwatch but by light, specifically sunlight. Every morning, when your eyes absorb the first light of day, a signal is sent to a tiny cluster of neurons in your brain, the suprachiasmatic nucleus. This acts as your master clock, syncing your body's functions to the Earth's 24-hour cycle. But what's fascinating is that every organ in your body, your liver, your heart, even your skin, has its own clock too. And these peripheral clocks communicate, adjust, and coordinate to keep your whole system running in time. When you travel across time zones, you disrupt this rhythm and feel it as jet lag. Your body is still ticking on one schedule, while the world around you follows another. It's a clash of biological and external time. Even more subtly, your cells divide on a schedule. Your hormones fluctuate. Your temperature dips and rises, all according to invisible rhythms that echo the cycles of the cosmos. So, time is not just around you, it's in you. It sculpts your mind, shapes your body, and flows not in hours and minutes, but in waves, pulses, and tides. The more we study time, the less solid it becomes. It bends in gravity. It stretches in motion. It dances in memory, pulses in biology. Maybe that's the real shape of time. Not a line, not a circle, but a symphony, one we're all part of. Entropy and the arrow. If time doesn't flow the same for everyone, then what makes it feel like it always moves in one direction? Why can't you remember tomorrow? Why do eggs crack but never uncrack? Why does the past feel fixed and the future like fog? To answer this, we need to visit a different kind of clock. Not the ticking of a watch or the heartbeat of your body, but a law. A rule so fundamental that it underpins everything from melting ice to dying stars. It's called entropy. In physics, entropy is often described as a measure of disorder. But really, it's about probability. There are more ways for things to be messy than for them to be neat. More ways for a deck of cards to be shuffled than to stay in order. More ways for molecules to spread out than to stay packed together. And so, over time, systems tend to move from order to disorder, not because there's a force pushing them, but because there are simply more disordered states than ordered ones. This tendency is encoded in the second law of thermodynamics, which says, in a closed system, entropy always increases. This is the only law of physics that cares about time's direction. All other laws, Newton's, Einstein's, even quantum mechanics, are time-symmetric. They work just as well forward or backward. But entropy moves one way.
That's why smoke doesn't go back into the match. Why shattered glass doesn't reassemble. Why you age. Why memories are always of the past. Entropy gives time its arrow. But that arrow isn't something the universe enforces like a traffic rule. It's a statistical tendency, a cosmic leaning. And yet, it governs almost everything you experience. Your thoughts? Entropic. Your heartbeat? Entropic. Even the structure of your brain, from the way memories are encoded to the way neurons fire, is built on the one-way nature of entropy. But here's something even more astonishing. The universe didn't have to be this way. At the moment of the Big Bang, the universe was in a state of extraordinarily low entropy, far more ordered than it had any right to be. And we still don't know why. That initial order is what allows the arrow of time to exist. As the universe expands, it becomes more disordered. Stars burn out. Galaxies drift apart. Entropy rises. But the deeper mystery is this. Why was the universe so tidy to begin with? This is one of the great unsolved questions in cosmology. Some physicists suggest it's a fluke. Others think we're missing a deeper principle, a kind of temporal gravity pulling everything forward. Or maybe time itself emerges from entropy. That is, perhaps time, the feeling of before and after, doesn't exist on its own. Maybe it's born from the increase of disorder. In this view, if somehow you could freeze entropy, you'd freeze time. Let that sink in. No disorder, no time. Now let's make it more personal. Think of your life like a sandcastle. Every moment adds another grain. But wind, water, and memory slowly erode it. Your experiences fade, your body ages, your energy disperses. That's entropy at work. But that same flow, that same impermanence, is what makes each moment precious. A perfect memory isn't the same as reliving the past. A photograph can't capture warmth. A melody means something only because it's fleeting. Entropy teaches us to cherish now. Because now is the only place we get to be. Entropy also connects deeply to the concept of information. In fact, physicist Ludwig Boltzmann's equation for entropy is carved on his tombstone, S equals K log W, where W is the number of microstates a system can take. Each possible configuration of atoms is a kind of message. And the more configurations possible, the more information and disorder the system contains. This leads us into the world of information theory, where entropy tells us not just about heat or randomness, but about uncertainty. When you receive a message, the more surprising it is, the higher its entropy. In this way, time's arrow can also be seen as the universe's way of communicating complexity, of unfolding itself. And nowhere is this more profound than in black holes. Black holes are not just dense objects. They are information vaults. In the 1970s, physicist Jacob Bekenstein proposed that a black hole has entropy proportional to the surface area of its event horizon. Then Stephen Hawking showed that black holes can emit radiation and slowly evaporate. But that leads to a puzzle. Where does the information go? If something falls into a black hole and disappears, and the black hole evaporates into nothing, does the information vanish too? That would violate quantum mechanics. This is known as the black hole information paradox, and it touches the heart of entropy and time. Because if information can be lost, what does that mean for memory, for history, for time itself? Some theories suggest that the information is somehow encoded in the radiation. Others propose that it gets smeared across the boundary of the event horizon, a concept called the holographic principle. This idea that our 3D universe might be a projection from a 2D surface is wild, but it might help explain why time feels like a moving film when underneath it could be static. Let's bring this back to Earth. In living systems, entropy behaves in fascinating ways. A living cell resists disorder. It builds membranes. It repairs itself, creates structure. So, is life fighting entropy? Not quite. Life is part of the entropic process. It consumes ordered energy, like sunlight or food, and releases disorder, like heat. It creates temporary pockets of order by increasing entropy elsewhere. Your body, your brain, your breath, they all burn energy to maintain structure. And when that structure breaks down, we call it aging, or death. But here's the beautiful twist. Entropy isn't just decay. It's also creativity. Without entropy, stars wouldn't burn. Winds wouldn't blow. No seeds would scatter. No thoughts would spark. Entropy gives rise to possibility. It allows the universe to try things, to evolve, to explore. And in your brain, entropy shapes your sense of time. You don't remember everything equally. You remember beginnings, endings, surprises, moments where order was broken or restored. That's your psychological arrow of time, built not just from clocks, but from meaning. When something unexpected happens, your brain records it. When life becomes routine, days blur. Time seems to pass faster when things are predictable. But entropy, in a sense, refreshes your clock. It brings novelty. So next time you feel time racing, introduce something new. Break the pattern. Shake the snow globe. Because entropy, while it dissolves things, also makes life vivid. And yet, not everything obeys this arrow so neatly. At the smallest scale, the quantum world, something strange begins to happen. Particles don't behave like tidy little marbles. They blur. They superimpose. They entangle. And in this microscopic world, time gets weird. Particle can interfere with itself. It can exist in a kind of timeless haze until observed. In fact, one of the great mysteries of quantum mechanics is whether time exists at all at this scale, or whether it's something that only appears when you zoom out. Some theories, like those involving quantum gravity, suggest that time isn't fundamental. It's not built into the fabric of the universe. It's a kind of illusion, a convenient approximation we use because we're too big and slow to see the true nature of reality. This may sound absurd, but in quantum cosmology, equations describing the entire universe don't even contain a time variable. It just isn't there. Instead, the universe may be like a timeless sculpture, every event, every state, every configuration coexisting. And we, as conscious beings, are tracing a thread through that sculpture, building a story one moment at a time. So maybe entropy gives time direction. Maybe our biology gives it rhythm. Maybe our minds give it meaning. But what is it, really?
That question, so simple on the surface, takes us to the edge of physics, of philosophy, of what it means to exist at all. And we're only halfway through the story. We'll explore how time isn't just something you live in, but something you might be able to shape, and how, in strange corners of the universe, time behaves like a mirror or a maze. Time as a dimension. Time has always felt like something we move through. From the moment we wake to the moment we sleep, from childhood to old age, we are traveling step by step through a one-way tunnel we can't turn around in. But what if time isn't a tunnel at all? What if it's a landscape? And what if we're not really moving through it, but rather revealing it like a flashlight sweeping across a still painting? In Einstein's theory of special relativity, time is no longer an isolated thing. It's joined with the three familiar dimensions of space, height, width, and depth, to form what we now call spacetime. This wasn't just a poetic way to think. It was a radical shift in physics. Imagine spacetime as a four-dimensional fabric. An event like the birth of a star or your first kiss is not just a place in space, but also in time. It's like putting a pin in a map that has both where and when. In this view, past, present, and future aren't flowing. They just are like a frozen loaf of bread, where each slice is a different moment in time. You, the observer, experience one slice at a time. But the loaf already contains all of it, all of you. Your birth, your death, every heartbeat in between. Einstein once wrote after a friend passed away, "Now he has departed from this strange world a little ahead of me. That means nothing. People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. Let that sit with you. To us, time feels like something that flows. To physics, it may be something static, unchanging, complete. So why don't we experience it that way? Why can't we visit next Thursday like we visit the next room?" The answer lies in something called the light cone. Imagine yourself standing in space at a single instant. From that moment, light can only reach so far, so fast. It travels outward at a fixed speed, the speed of light. The region it can influence and be influenced by forms a cone stretching through time. Anything inside that cone is part of your causal universe. Anything outside might as well not exist for you. Not yet. And so, your experience of now is not a universal moment. It's a personal, localized boundary of cause and effect. If someone is on the other side of the galaxy, their now isn't your now. They might already be living in your future, or still catching up to your past. This relativity of simultaneity means that now is not universal. It depends on where you are and how fast you're moving. Which brings us to an even stranger idea: time dilation. According to relativity, time moves slower for objects in motion relative to others. The faster you go, the more time stretches. This isn't science fiction. It's been measured. Astronauts in orbit age slightly slower than we do on Earth. Their clocks tick a tiny bit differently. And this gets more extreme the faster you go. Approach the speed of light, and your seconds stretch into minutes. Your hours into years. Imagine a spaceship traveling at near light speed for what feels like 1 year on board. When it returns to Earth, perhaps 10 years have passed here. To the traveler, it was just one trip around the sun. To us, a decade disappeared. This isn't just about motion, it's also about gravity. In Einstein's general relativity, gravity isn't a force pulling things downward. It's the curvature of spacetime caused by mass. The more massive an object, the more it warps the fabric of time itself. This means that time moves slower near heavy objects. Stand near a black hole, and seconds for you might be hours for someone far away. This is known as gravitational time dilation, and it's been confirmed experimentally, even with sensitive clocks placed at the tops and bottoms of tall buildings. Time isn't constant. It bends. It stretches. It flows differently depending on where and who you are. So when we say, "What time is it?" maybe we're asking the wrong question. Maybe the real question is, for whom, and where, and how fast? Time, then, is not the same for everyone. It's elastic, personal, contingent, and that means, in some strange but real sense, time is not fixed. It's relative, malleable, alive. That changes everything. It means that in some corners of the universe, the future may already have happened, and the past may not be fully gone. It means that somewhere, right now, another version of you is waking up or still asleep or long gone, depending on the frame of reference. It means that time, like space, might not be something we're trapped in, but something we can one day navigate. The mind's clock. For all its complexity in physics, time is something we feel long before we understand it. A newborn baby has no concept of hours or years, yet it quickly begins to sense patterns. Day and night, hunger and sleep, the rhythm of breath, the cycle of need and comfort. Before we ever wear a watch, our bodies are already ticking. This internal sense of time, the biological clock, is one of nature's oldest inventions. Every living thing, from humans to plants to tiny cyanobacteria, follows a kind of daily rhythm called the circadian cycle. It's roughly 24 hours long, synchronized with Earth's rotation and the rising and setting of the sun. In humans, this clock is controlled by a tiny region in the brain called the suprachiasmatic nucleus, a cluster of about 20,000 neurons tucked deep within the hypothalamus. It acts like a master conductor, orchestrating everything from hormone release to body temperature to sleep cycles, all based on what time it believes it is. But this clock is surprisingly flexible. If you've ever traveled across time zones and felt jet lag, you've experienced the mismatch between your biological time and the local time. Your body doesn't care that the sun is up. It still thinks it's 2 a.m. With enough exposure to light and daily routine, though, it slowly recalibrates. The clock adjusts. You rejoin the world. But the mind doesn't only sense time. It shapes it. Think about how time feels in different moments. A minute of holding your breath feels longer than a minute of laughing with a friend. An hour at the dentist stretches painfully, while 3 hours at a concert vanish in a flash. Why? Because the brain doesn't measure time like a stopwatch. It reconstructs it based on attention, emotion, and memory.
Moments packed with new experiences feel longer in retrospect. That's why childhood summers felt endless, because so much was unfamiliar, unfiltered, intense. As we grow older, routines solidify, days blur, the novel becomes the known. And so, time seems to accelerate, not because clocks tick faster, but because we stop noticing. This is called the holiday paradox. Strange as it sounds, a vacation packed with activity may feel like it flew by while it's happening, but later, in memory, it feels much longer than a lazy week at home. We don't remember time. We remember change. Our brains compress sameness and expand difference. It's not just what happened. It's how surprising it was. That's why learning a new language, moving to a new city, or falling in love can stretch time's texture. Novelty slows down perception. Emotion deepens memory. And so, time, at least subjectively, becomes less about numbers and more about meaning. But this subjectivity can also be disorienting. In trauma, time can freeze. People report a slowing down, a surreal clarity, as if seconds are stretching into hours. During boredom, time crawls. During grief, it loses shape altogether. There are even neurological conditions that distort time completely, where seconds feel like hours, or people lose the ability to tell how long anything lasts. All this suggests that time, in our experience, is not just an external force. It's a neural construct, a sensation we build from inside. In fact, some researchers argue that consciousness itself is a function of time. We don't just think, we think across time. Each thought links to the one before it and anticipates the one after. Like a melody, the mind unfolds moment by moment, creating continuity. Without time, there would be no self, only flashes of disconnected perception. So in a way, you are made of time. Not time as the universe measures it, but time as your brain assembles it, from flickers of memory, expectation, and attention. And what's more, the same mind that feels time also manipulates it. We daydream into the future. We rewind the past. We imagine alternate timelines and simulate choices not taken. This is one of the brain's greatest powers: mental time travel. It lets us relive, regret, rehearse. It lets us ask, what if? No other species seems to do this in the same way. And so, while physics tells us that all of time may already exist, past, present, and future written in the loaf of spacetime, the human mind is the reader, turning each page, one by one, imagining what's ahead before it arrives. This brings us to a powerful, humbling idea. Maybe time isn't something we're inside of. Maybe time is something we create moment by moment, from the inside out. Echoes in the mind. Time for us is never raw. It is always processed, painted with the color of memory. And memory, that slippery, sacred function, does more than archive our lives. Constructs them. Without memory, time would have no continuity. You wouldn't know where you came from, who you are, or even what the beginning of this sentence was. You'd be stuck in a constant present, a moment that resets endlessly, like waves crashing but never pulling back. In this way, memory is the thread that stitches moments together. But here's the strange part. Memory doesn't play back reality. It rebuilds it each time slightly differently. Neuroscientists have found that recalling a memory isn't like opening a file. It's more like repainting a scene from scattered fragments, influenced by your current mood, expectations, and beliefs. In essence, remembering is a creative act. Every memory is shaped by the present you. And so, even the past is never fully fixed. But if the past is flexible, what about the future? You might be surprised to learn that the same brain regions involved in memory are also used when imagining the future. This shared circuitry, known as the default mode network, is active when your mind wanders, when you daydream, when you plan. It's the home of your personal timeline, the inner narrative that stretches from long ago to what's still to come. This system allows you to simulate time, to imagine consequences, envision goals, prepare for what's next. In fact, some researchers believe that our ability to mentally travel through time is what sets humans apart from other animals. A squirrel may bury nuts for the winter, but it doesn't imagine itself watching snow fall by the fireplace. It doesn't ponder the meaning of its memories or question how time flows. We do. We live in what psychologists call the temporal self. That is, our identity is not rooted in the now but stretched across time. We remember our past, compare it to our present, and project a story into the future. This is both a gift and a burden. It allows us to learn, grow, hope, but it also makes us worry, ruminate, regret. We live not just in the present, but in an echo chamber of what was and what might be. And yet, that echo is what gives life its meaning. Consider how time shapes love. We treasure relationships not only because they exist, but because we know they are finite. Time gives weight to our choices, urgency to our dreams. If we lived forever, if time were infinite and flat, would we still care? Would we still fall in love the same way, knowing there's no ticking clock? Would we still feel awe at a sunset, knowing there would be endless more? Paradoxically, it is the limits of time that give it power. In fact, many spiritual traditions frame enlightenment as a kind of escape from time, a return to the eternal present. Think of monks who sit in silence for hours, dissolving their awareness of past and future, or mystics who speak of timeless unity, where the self dissolves into something vast and still. What they seek is not immortality, but timelessness, a freedom from the grasping, running, fearing mind that time so often creates. It's a reminder that while time may structure the universe, our experience of it is far from fixed. You can be 30 years old and feel ancient. You can be 80 and feel like a teenager again. Time lives in the body, but it also dances in the mind. And sometimes, just sometimes, it stops altogether. In those moments, when you're completely absorbed in music, or lost in a story, or staring at the stars in awe, time becomes invisible. You forget what hour it is, what year it is, even who you are. You dissolve into the now. These are called flow states, and they offer us glimpses of timelessness, brief but profound escapes from the ticking clock. Ironically, by forgetting time, we often feel more alive. This suggests that time, at least in how we live it, is as much about attention as it is about duration.
A moment of wonder can stretch forever. A year of routine can shrink to nothing. So perhaps the key is not to control time, but to pay attention to it, to notice it, to fill it with meaning, not just by scheduling tasks, but by inhabiting moments, by listening closely, loving fully, observing carefully. Because in the end, time is not just a thing that passes. It's a thing we pass through, shaping it as it shapes us. Oceans of time. When we think of time, we tend to think in human-sized pieces. Minutes, days, years. We count birthdays, anniversaries, deadlines. We live inside a calendar built for farming, work schedules, school semesters. Time feels structured, linear, manageable, a river we can measure with a wristwatch. But step outside the human scale and time begins to dissolve. It stretches. It warps. It becomes strange. There is a concept in geology called deep time. It's not just about a long period, it's about a kind of scale our minds were never meant to grasp. Try to imagine 100 years. That's easy. You can picture the 1920s, imagine old photographs, vintage cars, crackling radios. Now try to imagine 10,000 years. Harder, but still within reach. Maybe cave paintings, ancient tribes, mammoths roaming grasslands. But now imagine 1,000,000,000 years. Not 100 years. Not 10,000. 1,000,000,000. That's time so vast that entire mountain ranges can rise and crumble. Oceans form, shift, disappear. Species appear, evolve, and vanish, not once but thousands of times. And the Earth? The Earth has been spinning through 4.5 billion years of such change. To make that more real, if Earth's history were condensed into a 24-hour day, modern humans, everything from the first stone tools to smartphones, would show up in the last few seconds before midnight. Dinosaurs? They dominate the evening hours. Oceans? They would have formed before lunch. Life? Simple microbes would have been there before dawn. Most of time, even on our own planet, is not human time. It is planetary time, geological time, time that moves not by clocks, but by tectonic plates and extinction events. And even that, even 4.5 billion years is nothing compared to cosmic time. The universe, as best we know, is about 13.8 billion years old, which means that for 3 times the age of Earth, galaxies have been colliding, stars being born and dying, black holes spinning silently in the dark. The light from some galaxies that we see in telescopes today began traveling toward us before our planet even existed. Let that sink in. The past is still arriving. But time in the cosmos isn't just long. It's bent. In Einstein's theory of general relativity, time is not separate from space. It's woven into it like threads in a single fabric. Massive objects like stars and planets don't just sit in space. They warp the very space-time around them. And where space is bent, time is bent too. This means that time can run faster or slower depending on where you are. Near a massive planet, inside a gravity well, even inside a spaceship moving near the speed of light. It's not science fiction. We've measured this. In fact, GPS satellites have to correct their internal clocks for both gravitational time dilation and relative velocity, or their positioning would slowly drift. So up there, in orbit, time is actually ticking just a little faster than it is for you on the surface. Now imagine taking that to the extreme. Imagine falling toward a black hole, a place where gravity is so intense, it bends space-time almost to breaking. From your perspective, time might feel normal. But to someone watching from a safe distance, you would appear to move slower and slower and slower until you seem frozen, forever falling but never reaching the event horizon. In a very real sense, your time would diverge from the universe's time. It raises a wild thought. Maybe there is no universal now. No single cosmic tick-tock that keeps everything in sync. Time, in the deepest physical sense, may not be absolute. It's relative. It depends on where and how you are. And so, while we experience time as a steady rhythm, a constant stream, reality may be far more fluid, more fragmented, more strange. But even stranger still is what lies ahead. Because just as time has a deep past, it also has a deep future. And it is vast beyond imagining. In about 5 billion years, the sun will run out of fuel and swell into a red giant, possibly engulfing Mercury, Venus, and Earth. If humans still exist, they'll need to be far away by then. Eventually, even stars will stop forming. Galaxies will fade. Matter will decay. And the universe will slide into what physicists call the heat death, a state where everything is so spread out, so cold, so still that no usable energy remains. That final future is trillions of years away. But even then, time won't stop. It will stretch on, empty and dark, far beyond the lifespan of stars or species. A canvas with no painter, a clock that ticks without purpose. And yet, here we are. A fragile moment of awareness, a spark in the vast timeline, thinking, wondering, speaking of time, inside time. It is humbling, it is dizzying, it is beautiful, and it's only the beginning. Evolution through the lens of time. When we peer into deep time, we see that life itself is a response to it. In a sense, evolution is nature's memory, written not in books, but in DNA. Each mutation, each adaptation, each extinction is part of a long conversation between life and time. You are the product of 4 billion years of change. Every atom in your body once belonged to stars that lived and died long before Earth ever formed. Your bones are shaped by creatures that crawled from the sea. Your thoughts ride on neural networks sculpted by time, generation after generation learning to move, to feel, to remember. Time is not just something we move through. Time moves through us. And through life, time becomes organized, adaptive, aware. From the simplest microbes to the human brain, life doesn't just endure time. It begins to map it, to respond to it, and eventually to question it. We build internal clocks, circadian rhythms that hum quietly in our cells, keeping us in sync with Earth's rotation. We develop memory, a way to store the past, and anticipation, a way to guess the future. We are time-aware creatures, but we're also time-bound. We can't rewind. We can't pause. We can't see ahead, not really. So we tell stories. Time and the narrative mind. Human beings understand time best through narrative. That's why we love stories. A story has a beginning, a middle, and an end. It gives shape to the formlessness of life. It helps us make sense of cause and effect, of growth and loss, of the passage of time itself. In a way, stories are how we feel time. Think of your own life. What do you remember?
What do you remember? Not every hour, not every moment. You remember the peaks, the transitions, the changes, the story beats. We compress years into moments and moments into meaning. Time in our minds is not clock time. It's emotional time. It stretches and shrinks. It loops and lingers. A boring afternoon can feel eternal. A joyful year can vanish in a blink. And this emotional time is deeply tied to memory. Psychologists have long known that memory and time perception are linked. People with amnesia often lose their ability to imagine the future. Why? Because imagining the future uses the same brain networks as remembering the past. Your memory isn't just a record. It's a tool for prediction. The more memories you have, the more richly you can simulate what might happen next. And that's perhaps one of the greatest gifts time gives us, the ability to imagine. To not just react to the now, but to plan for what could be. The mystery of the present moment. But here's the paradox. We live entirely in the present. The past is memory. The future is imagination. But the present, this flickering, ever-moving now, is where everything happens. And yet, we can never quite catch it. By the time you notice the moment, it's already gone. Physicists struggle to even define the present in objective terms. In relativity, there's no universal now. Two observers moving differently through space will disagree on what events are simultaneous. So what is the present? Some philosophers argue that it's an illusion, a trick of consciousness that helps us organize our experience. Others say the present is all that's real, that the past is gone and the future doesn't yet exist. Still others believe that all moments in time, past, present, and future, exist equally, like pages in a book, and our consciousness simply moves through them. In this view, time is like space, all laid out, all there. We just experience it one slice at a time. It's called the block universe theory, and it challenges everything we think we know about change and flow. If all moments already exist, is anything really moving? The river or the illusion? Imagine watching a movie. The film is already complete, beginning to end. But when you watch it, you experience suspense, surprise, emotion, because you're only seeing one frame at a time. Some scientists think that may be how time works. The universe is the film reel. We're the projector, and consciousness gives us the illusion of motion. Others push back, arguing that time's passage is real, fundamental, not just an illusion. Quantum physicists, too, wrestle with time. In quantum mechanics, time behaves differently. It's often treated as a background parameter, fixed, external, while space and energy fluctuate. But in some approaches to quantum gravity, like loop quantum gravity or causal dynamical triangulations, time might emerge from more basic processes, like a shadow cast by something deeper. In these models, time isn't fundamental, it's emergent. Just as temperature emerges from the movement of atoms, time may emerge from the interactions of fundamental elements we haven't yet fully discovered. So what is time? That's the question we started with. And now, after diving through clocks and cosmos, entropy and evolution, black holes and memory, the answer remains elusive. Time may be a dimension, process, an illusion, a flow, a structure, a habit of consciousness. a mystery still waiting to be unfolded. But one thing is clear, whatever time is, it has shaped everything we are. From the birth of atoms in dying stars, to the rising and falling of civilizations, to this moment right now as you sit listening, breathing, drifting into thought, time is not just a measure. It is a medium. We live in it. We are made of it. And somehow we're able to reflect on it, like a wave realizing it belongs to the ocean. Time as culture, memory, and meaning. Time is not only etched in stars and skeletons, it's woven into culture. Every society that's ever existed has tried to make sense of time, to tame it, to honor it, to survive within its flow. Ancient people watched the heavens, tracing the paths of stars and planets, crafting calendars from cosmic rhythm. They tracked solstices and equinoxes, planted crops with the moon, and measured years by the rising of constellations. In a way, time became the first shared language. The movement of celestial bodies told us when to harvest, when to rest, when to mourn, and when to celebrate. Our ancestors did not separate time from nature. They felt it in the wind, in the changing leaves, in the migration of animals. For them, time wasn't a machine. It was a circle, the circle and the line. In many ancient cultures, time was cyclical. The seasons turned, life returned, stories repeated. Hindus speak of vast cosmic cycles, yugas and kalpas, each stretching for millions or even billions of years. The universe is born, unfolds, dissolves, and begins again. In Buddhism, time is like a wheel, samsara, the endless turning of birth, death, and rebirth. Indigenous traditions around the world echo this sense of eternal return. Nature moves in spirals, not straight lines. But then came a different view, the linear time of the West. Rooted in the Abrahamic religions, this concept gave time a direction. A beginning, a middle, and an end. Creation, revelation, judgment. History was going somewhere. And with the rise of science and industry, linear time became dominant. We started measuring everything. Seconds, hours, schedules, productivity. Time became quantified, not something to be lived with, but something to be used. We invented mechanical clocks, then atomic clocks, then networks of satellites to synchronize time globally. Now, time isn't just a flow, it's a commodity. We save time, waste time, manage time. We fill our calendars, race the deadlines, multitask every moment. But in all this precision, have we lost something? The cost of clock time. Clock time is powerful. It lets us coordinate across continents, launch rockets to Mars, perform surgery down to the millisecond. But it can also make us forget the felt experience of time. Have you ever looked up and realized hours had vanished? Or felt a day stretch endlessly while waiting for news? Time can be rigid or liquid, structured or deeply subjective. In modern life, we often live ahead of ourselves, planning the next thing, rushing to meet it, rarely pausing to inhabit the now. In many ways, we are time-anxious creatures, afraid of wasting time, afraid of running out of it, afraid of being forgotten by it. But maybe the answer isn't to escape time. Maybe it's to remember that we are part of it. Just like the tide doesn't resist the ocean, perhaps we, too, can learn to move with time, not against it.
Rituals of time. Across cultures, we've invented rituals to reconnect with the rhythm of time. We light candles for those who've passed, marking their memory in flame. We gather at new moons and new years to begin again. Birthdays, anniversaries, funerals, harvest festivals. All are ways of placing human life inside cosmic time. Even the act of storytelling, sitting around a fire, passing down tales, is a ritual of temporal anchoring. In these moments, time slows down, becomes sacred, becomes shared, and that may be one of time's quietest powers, to remind us that we are not alone. that others have come before us, that others will come after, and that in this brief stretch between arrival and departure we belong. Time and mortality. No conversation about time is complete without touching the tender thread that runs beneath it, mortality. Time reminds us that everything we love will one day change, that nothing lasts forever, and yet, in that impermanence lies depth. Would life mean as much if it never ended? Would beauty touch us as deeply if we knew it would always be there? Perhaps it is the very presence of time, its ticking, its turning, its transience, that makes love meaningful, that makes art moving, that makes each sunrise, each word, each breath, sacred. We may fear death, but time also teaches us how to live, teaches us presence, gratitude, urgency, wonder, and in the end it teaches us release. Pause before the end. As this part of our journey draws to a close, take a moment. Let go of the clock. Breathe in and out. Feel the present, not as a point on a timeline, but as a place, a living moment, filled with all of your memories, all your future hopes, and this quiet breath in between. We don't need to fully understand time to be transformed by it. Sometimes it's enough just to notice it, to feel it pass, to walk gently beside it, and to remember that in this vast universe of stars and gravity and entropy and space, you are here, right now, alive, time beyond the human mind. We've wandered through clocks and cosmos, through physics and philosophy, through memory and mortality. But even now, a strange question lingers. What if time, as we know it, is just a shadow? A simplified story our minds tell to make sense of something far more mysterious? Let's leave behind the ticking of watches. Let's even let go of space-time as Einstein imagined it, and ask boldly, what lies beyond? The problem with now. Let's start with something deceptively simple. Now. Right now, you're hearing these words, or reading them. There's a sense of immediacy, of presence. You feel that this moment, this now, is special. But here's the twist. Physics doesn't agree. In Newton's universe, now was universal. It ticked the same for everyone, everywhere. But in Einstein's relativity, there is no shared now. Every observer has their own slice of space-time. Someone speeding past you on a rocket ship would experience a different now entirely. So what does that mean for the present moment? It might be an illusion, a construct of consciousness, not a feature of the universe, but of the brain. We piece together sight, sound, touch, and thought into a coherent now. But the data arrives in fragments across milliseconds. Our brain edits the footage, smooths it over, and presents it to us as one flowing scene. This means you are always living slightly in the past. The now you feel has already happened, like a film with a few frames of delay. Is the flow of time real? We don't just believe in now, we believe in flow. That time moves, that the future becomes the present, then the past. But in physics, there's no such flow. The equations work just as well forward or backward. They don't prefer a direction. Time in the math just is. So where does the river-like feeling of time come from? Many physicists argue it's a product of entropy, the arrow we explored earlier. Low entropy to high entropy, ice melting, eggs breaking, stars burning out. But the deeper truth might be that nothing moves through time. Time doesn't flow. Instead, we move within a static landscape of moments. Imagine a DVD. All the scenes are already encoded. But when you press play, the story seems to unfold. Your consciousness might be the lens that plays time, frame by frame, moment by moment, and perhaps the film is already complete. The block universe. This idea leads to one of the strangest and most haunting theories in modern physics. The block universe. According to this view, all moments in time, past, present, and future, exist equally. They are all real, all there. We don't move through time like a train through stations. We are a part of the track. Our birth, our childhood, this moment, they all coexist. We just experience them one at a time. Like pages in a book, the entire story exists at once. But you, the reader, move through it in sequence. In this view, there is no objective now. No privileged present. Only different slices of the block depending on where and when you look. It's unsettling. It means your future already exists, that your memories are just as real as your hopes. And yet, it also offers something comforting, that nothing is ever truly lost, that the moments we've loved, the people, the places, the joys are not gone. They are still there in their coordinates within the block. You've simply moved on. The quantum wildcard. But before we close the book entirely, quantum mechanics knocks on the door, where classical physics paints a smooth, continuous universe. Quantum theory introduces uncertainty. Particles don't have definite positions or speeds, not until we measure them. They exist in superpositions, in clouds of probabilities. Time, too, becomes fuzzy. In quantum gravity, a theory not yet complete, time might emerge from something deeper. It may not be fundamental at all. Some radical theories propose that time is just a statistical illusion, that in the deepest layers of reality, there is no time, just patterns, relations, change without a ticking clock. In these views, our experience of time may be a kind of emergent property. Like temperature isn't real for a single atom, but only appears when you have a bunch of them moving together. Time may be collective, a story that emerges from complexity. If that's true, then time is not a container we live in, it's something we create. The mind as a time machine. We often think of time as external, a thing out there. But the human mind may be one of time's most important instruments. We can remember, we can imagine, we can simulate futures, regret the past, and plan with precision. Our minds stretch far beyond the now.
This ability, called mental time travel, may be what makes us human. It allows us to tell stories, build civilizations, invent religions, and seek meaning. We don't just live in time. We are time-aware creatures. And this awareness comes with a cost. We know we are temporary. We know our time will run out. That burden of consciousness wrapped in impermanence. It's the source of both our sorrow and our beauty. Because knowing we'll die makes every moment more vivid. Where science meets the soul. So far, we've touched physics, wandered through consciousness, and stepped beyond the edge of what the equations allow. But let's ask something more personal now. What does time mean to you? Not in hours or schedules, not in theories or timelines, but in lived experience, in the quiet truth of simply being alive. Time is loss. Time is the price we pay for everything we love. The child who runs through the garden will one day leave home. The friend who laughs with you today will someday become a memory. The pet who curls up beside you will grow old and sleep forever. We feel time in the ache of goodbye, in the wrinkle by the eye, in the silence where someone used to be. You can't touch time, but you can feel its fingerprints all over your life. There's a peculiar sadness baked into awareness. Because the moment you realize something is beautiful, you also realize it's slipping away. Maybe that's why humans take photos, why we write in journals, why we build cathedrals, write poems, and press flowers in books. We are trying, in our own fragile way, to make something stay. Time as meaning. But here's the paradox. Time also gives things their value. If nothing changed, if everything lasted forever, would anything truly matter? A sunset is beautiful because it fades. A song moves you because it ends. A hug is precious because it won't last forever. We treasure things precisely because they are temporary. Your life, your entire story, is made of moments you will never get back. And that's what makes them yours. Time is the canvas, but meaning is the art. And you, with every choice, every memory, every breath, are painting something no one else can. Cosmic time versus human time. Let's zoom out one more time. Back to the stars. Back to cosmic time. In the scale of the universe, your whole life is a blink. Less than a flicker. You are here for barely a whisper between the birth of the stars and their final collapse. But in that whisper, you feel love. You ask questions. You make music. You imagine infinity. How strange. How profound. That something so brief could be so full. That a creature made of dust and water could dream of galaxies and gods, and wonder where the time has gone. The stars may not care, but the fact that you do is a kind of miracle. Does time have a purpose? Science doesn't give time a purpose. It's not a force with a direction or a destination. But humans are meaning makers. We invent purpose. We chase it. So, is time for growth? For evolution? For learning? Or is time just a backdrop and you give it the purpose? Maybe the universe isn't telling a story, but you are. And your story unfolds in time. Moment by moment. Word by word. Heartbeat by heartbeat. Timelessness and stillness. Ironically, some of the most profound human experiences feel timeless. A moment of awe in nature. A deep meditation. A sudden flash of insight or connection. In those moments, the clock fades. There's no past, no future, just presence. These are the moments people describe as sacred, eternal, weightless. It may be that true peace is not in controlling time, but in letting go of it. To stop grasping, to stop chasing, to simply be. And in that stillness, you may touch something more vast than all the ticking clocks. You are a moment in time. You are not outside of time. You are not simply moving through it. You are time. You are a pattern of change. A ripple in space-time. A song that began at birth and is still being written. And one day your song will end. But like all waves, it will have touched the shore. Left echoes in the air. Carried other notes along with it. You may not choose the length of the song, but you choose the melody. So what will you do with your time? Final reflections. The gift and the mystery. Maybe time is both the thief and the gift. The shadow and the light. The question and the answer. It breaks us, and it builds us. We age. We grieve. We learn. We love. And if we are lucky, we awaken not to control time but to appreciate it, to hold it gently like water in our hands, to say, I was here, I saw beauty, I felt wonder, I lived. The end of time, the beginning of awe. Let's return once more to the beginning. Before there were stars, before there were atoms, before there was time itself, there was something, or perhaps nothing. Even the words fail us. And from that silence, something began. A spark, a surge, a birth of space-time. The universe began to change, and from that change, time was born. In a very real sense, time is not just a backdrop to the universe. It is a feature of the universe. It exists because the universe does. And maybe, just maybe, it will end when the universe ends, too. Time's future. Where is time heading? If the universe keeps expanding forever, the stars will eventually burn out. Galaxies will drift apart into darkness. Black holes will evaporate. And in the distant, distant future, after unimaginable epochs, even change itself may cease. That's what some physicists call the heat death of the universe. No more usable energy. No more stars. No more time, at least not as we know it. It's hard to imagine a universe that exists but no longer evolves. But even then, In that vast silence, the ghost of time will still linger, in the memory of everything that once was. But is that all there is? Maybe not, because for all we know, our concept of time is limited by our biology, our physics, our perspective. Some theories suggest time could loop back on itself. Others suggest a multiverse, infinite timelines branching off endlessly. And then there's quantum theory, where particles can be entangled across time, or even behave in ways that make the future influence the past. In short, we still don't understand time. Not fully, and maybe we never will. But here's the thing. Understanding isn't the only goal. Sometimes it's enough to marvel, to wonder, to feel awe. The sleepy minds, a final whisper. As we come to the end of our journey, take a moment to breathe. Wherever you are right now, curled up in bed, walking quietly, or resting your tired eyes, this moment is yours. Time is flowing around you, within you, through you. And for this short sliver of eternity, you've paused to listen, to learn, to drift.
And that's beautiful. Here on the Sleepy Minds, we explore not just the facts, but the feeling of the cosmos. So thank you for your curiosity, for your attention, and for your presence. If this journey through time brought you peace, wonder, or even a new question to carry into your dreams, consider subscribing, leaving a like, or simply joining us again. There's more to explore, always, because as long as there is time, there will be mystery. And as long as there is mystery, we will be here to wander through it, slowly, softly, together. Good night, and until next time, stay curious.